Hello and welcome back to my channel. I'm Kazi Salasin. As I've previously introduced myself, I'm an electrical and electronics engineer from Bangladesh. Welcome back to my channel. As we previously talked, I was discussing discussing something called a microcontroller or a microprocessor. So these are different from the microprocessors that go to run your laptops or your cell phones or your desktops. These are basically microcontrollers. They're more specific. This is for you to look at it once more. This is from a company called Arduino. They're designed in Italy, but I'm pretty sure most of these things are assembled and manufactured in China, since they have the lowest manufacturing rates as well. But everything else is cheaper in China. So I mentioned in my last video that I'm going to talk about some of the things that I've mentioned which are not necessarily self-explanatory in another video, and I've also made some mistakes. So let's begin with the mistakes first. The mistake that I made in the previous video was that I called a microchip or a microprocessor. This is not a microchip or a microprocessor. What this is a microcontroller. The two words are microprocessors and microcontrollers. A microprocessor is basically the chips that control our computational devices, the traditional or more prevalent computational devices that we're aware of or are used to being around. These are not microprocessors. These are microcontrollers. There's a difference. Microcontrollers are versatile, but they are both more limited in their capacity as well as capability. Another mistake that I made in my previous video was that I called it a 32-bit microcontroller. It's not a 32-bit microcontroller. It's an 8-bit microcontroller with 32 kilobytes of memory. The Atmega 32 chip, let me show it. This is the chip I'm talking about. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, 14. 14 into 28 pins. So these pins go inside and they are logged in. These pins are essentially through that middle layer that I've previously mentioned, connected to these pins, to these embedded components that go inside, and all of this comes together to create the input-output terminal of a microcontroller like this one, Arduino Uno R3. Like I've previously mentioned, they're incredibly versatile. You can use them to create, let's say, the prototype of a traffic control system, the prototype of a digital system that runs a manufacturing unit. So for example, let's say you want to pasteurize milk at a really large scale, right? And usually you do it manually, but doing it manually is becoming more and more problematic due to shortage of labor in your area, or simply because of the fact that there is a lack of skill in the workforce that you have. That's where this automation comes in. You can practically program this to run any sort of motors as long as you have a proper power supply attached to it, and use that to create automations that will end up replacing manual labor which is either less than optimally skilled or expensive comparatively. So for example, let's say you pay someone 10,000 Bangladeshi taka for a month of their labor, or 20,000 taka for their labor, replace them with, I don't know. So I bought this one for 630 taka. These come at a range of Bangladeshi takas. So basically, I've seen websites offering them at 360 taka all the way up to 930 taka. So based on that, they're going to be fairly within 1,000 taka. And I purchased this in by the end of 2016, and this is 2025 now. This is still functional, which means this has at least a lifespan of 9 years. And if you divide that by 1,000 taka, if you divide 1,000 taka, or like in my case 400 taka or 360 taka by 9 years, 9 4 is 36, so it's 40 taka per year, the cost of this microcontroller. Literally 40 taka per year. If you think about the alternative, right, the alternative is not at all anywhere near this cheap. Anyway, moving on, other things that I previously mentioned was I was going to talk about the cable. So this is basically the cable that comes along with this microcontroller, and as you can see, this cable has two completely different ports on two ends. Okay, one is of a rectangular shape, the other is, well, seemingly trapezoidal. It's not trapezoidal. This is 1 2 3 4 5 6. It's a hexagon. It's not a regular hexagon. I know a lot of you are going to be technically savvy and you're going to catch this, but this is also a hexagon, just not your regular hexagon. Hexa means 6, gon means basically shape, like off or related to shape. So this is a hexagon, but not a regular hexagon, and this is a rectangle. And this is a USB connector. I don't know the name of this connector. I will figure it out and I will let you know on the next video. But for now, you need to know that this pin connects to this port, and you can use this to both transfer information from another computational device to this one. You can also use this to power, like for example, let's say you have a power bank, you can attach this and boom, this will happen. And this is basically your analog signal input, another one of those, and this can also be used as a power source input. But anyway, moving on, the other stuff that I have previously mentioned that I'm going to explain was a bunch of other components, and I'm not going to get into them right now because I'm going to create a whole series on electrical and electronics engineering and the components. For example, I previously mentioned that that this is a FET, a switching device. Now a FET is, the word is small, like the abbreviation is small, FET is just 3 alphabets, but it's not nearly as simple or as small as you may think. Okay, so there is super interesting physics underlying this device. That's number one. Number two is there are behavioral characteristics as well as application wise differences regarding these switches, and they're everywhere, starting from the insides of your cell phones to microcontrollers like this, airplanes, your car, your motorbikes, your AC, basically any advanced electronics that you find around. It's highly likely that it comes with a FET of its own. Now, what kind of FET it is, that's a different conversation, but it comes with a FET, field effect transistor. It begins with the concept of a transistor, and I'm going to create a completely separate video regarding what a transistor is. But for now, just know these are not to be discussed as part of a video. These require entire videos of their own. The last thing that I'm going to talk about is basically I'm going to host a live stream because I ended up writing a thesis on applied machine learning almost 4 years ago, which is only recently getting citations. People from China as well as the US, oddly from the sphere of economics and statistics, are building up on the work that my team was involved in. And I have a lot of other independent research that I'm currently involved in under the domain of artificial intelligence, specifically machine learning, deep learning, and like I'm still within the domain of learning based artificial intelligence. I have not yet deployed an AI product of my own, but that being said, the work I have done is also impactful. It is unique and interesting in its own way, and I hope to host streaming session soon, and I'll hopefully my thesis partner is going to join me as well, and we're going to talk about some really interesting cutting edge research that is currently happening around the world under the domain of electrical and electronics engineering as well as artificial intelligence. And we're basically going to use that stream to kickstart a whole series under artificial intelligence, where I'm going to create 20-minute long videos on everything from scratch, starting with the mathematics involved with applied machine learning and artificial intelligence, the techniques and the tools necessary, the languages involved, the history of the field, where it is currently, where it is headed, what opportunities lie ahead. So it's going to involve a lot of super technical as well as super interesting and fascinating content. I hope you will like, share, and subscribe if you find this content useful and impactful. See you soon.